Okay, this is a video on question on lesson 12. So again, lesson 12. I think this was on the assignment 3.3, and I notice here it's question 55. I better fix that. Okay, we're back. So this is question 55. I want to make sure I got the right question this time. All right, two trains leave the station traveling in opposite directions. Okay, so I'm just going to put a box here going this way, a box here going this way. Two trains leaving the station. Now, remember on problems like this, rate times time is equal to distance. That is a very, very important formula. All right, now one train is 12 miles per hour faster than the other. One train is 12 miles per hour faster than the other. Okay, so if I call this one R, and this is a faster one, this would be R plus 12. It's faster. Okay. And in 3 hours, they are 300 miles apart. Okay, so, here we go. We have this train's over here, and this train ends up over here. And how far apart are they? Well, according to the word problem, they're 300 miles apart. Okay? All right. Now, the question says, determine the average speed of each train. So, what they're saying is if we do some math and we find this is 50 miles per hour, 50 miles per hour, then this one will be what? 62 miles per hour. We could call this one the slow train. We could call this the fast train. Okay, that makes sense? Now, how are we going to do that? All right, that is the question under consideration in this problem. So let's see. Well, we do know that the distance of the one train plus the distance of the other train has to equal 300. We also know that distance of the slow train is the rate of the slow train times the time that the slow train traveled. And the distance of the other train is the rate of the fast train times the time of the fast train. Okay, and again, that's 300. All right, that's really nothing new there. But one thing we do know that the rate of the slow train, we're calling that R. So I'm going to put an R here, okay? Now, the time of the slow train. Well, the key is right here. In 3 hours, they left at the same time, and they end up being 300 miles apart at the same time. So they're both 3 hours, okay? Plus the rate of the fast train is R plus 12, R plus 12 times its time, which is the same, 3 hours, okay, is equal to 300. Okay, now notice I have a linear equation of one unknown. I could clean this up a little bit and say 3R, right, plus we're going to distribute this 3, so that's going to be 3R plus 36 is equal to 300, okay? And of course now we have 6R, right, plus 36 is equal to 300. Now we're going to subtract 36 from both sides. Just move it over here, okay? 6R is equal to, what would that be? Well, it would be 264. Okay, check my math out on that. And then divide by 6, so R is equal to, well, let's see, 6 goes into 26 24 times, so that's 4 with 2 left over, and another 4. So I'm going to say 44 miles per hour, okay, is the rate R. So in other words, if this train is 44 miles per hour, what is the rate of this other train? Well, we're going to add 12. That would be 56 miles per hour, okay? And of course, if you did 3 times 56 plus 3 times 44, you should get 300. So the answer to the question is 56 miles per hour and 44 miles per hour. Now I know, I know that these problems could be a little difficult, but I got good news for you. They're not as difficult as this cartoon. So here we have this gentleman over here trying to get into pearly gates, and looks like this is Peter or some character. Okay, so he says, "Okay, now listen up. Nobody gets in here without answering the following question: a train leaves Philadelphia." So anyway, it's kind of funny. I call that the math phobics nightmare. A little humor there. All right, I hope this video helped you, and let me know. Okay, thanks.